Intro to Polynomials lesson. What is a polynomial? String of one or more terms in the form ax to the k power. No variable with negative exponents. There are no variables with fraction exponents and no variable in the denominator of a fraction. Degree. The highest exponent in the expression. If there is more than one variable, add the exponents. The constant 0 has no degree. Standard form. Polynomials in order from highest degree to lowest degree, or highest exponent to lowest exponent. Let's try some examples. 2x squared minus 1/4 x to the third plus 7 written in standard form would be negative 1/4 x to the third plus 2x squared plus 7. Okay, what is the degree? So our highest exponent is 3. So our degree would be 3. Okay, let's try the next example. So we have x to the negative 1 plus 4. Because of the negative 1 as an exponent, it is not a polynomial. So this example is not a polynomial. Okay, 5 minus x. Okay, let's rewrite this in standard form. So this would be negative x plus 5. Our x is raised to the first power, so our degree would be 1. Again, if there is not an exponent in a variable, then it is raised to the first power. Okay, let's rewrite this. It will be 2x, or negative 2x to the fifth power, plus 7x squared, plus x, plus 8. Our highest exponent is 5. So our degree would be 5. Okay. Ready for more examples? Okay. 5x to the third y. There are two different variables, so you have to add the exponents. So we have the exponent of 3 and 1. So 3 plus 1 is 4. So our degree, again, you have two different variables. You have to add the exponents, which x is raised to the third and y is raised to the first. So 3 plus 1 is 4. Okay, so negative 9 does not have a degree. It is not raised to an exponent. Anything that is just a constant is raised to the 0 degree. However, 0 is raised to nothing, so there is no degree. Okay, here we have x to the first, y to the second, and z to the fifth. Remember, when we are trying to find the degree, we have to add the exponents. So 1 plus 2 is 3. 3 plus 5 is 8. So our degree would be 8. Okay. Classifying polynomials. There are two methods of classifying polynomials. The first method is by degree. So if something is to the 0 degree, it is the constant. Some examples are 5 and -8. If it's to the first degree, it is linear, meaning that there is an x and or a y or one variable. If there are 2 degree, then it is a quadratic. It is a variable raised to the second power. If it's to the 3rd degree, it is cubic. It is a variable raised to the 3rd power. If it is to the 4th degree, it is quadric. It is a variable raised to the 4th power. If it's 5 plus degree, the name is number and degree and is raised to that power. The second method of classifying polynomials is by the number of terms. If it has one term, it is a monomial. Examples provided. If it has 2 terms, it is a binomial. Example is provided. And if it is 3 terms, then it is a trinomial. Example provided. And if it is 4 plus terms, it is a polynomial. Example provided. Just keep in mind, when you're counting the number of terms, they are separated by either an addition symbol or a subtraction symbol. Let's try some examples. So, 5x. Let's name this by both types. So, it is raised, has 1 degree, so it is linear. And it is 1 term, so it is a monomial. Okay, so this is to the 4th power, so it is a quadric. And it has 2 terms, so it is a binomial. Okay, so this one is raised to the 3rd power. So it is a cubic polynomial. And it has 1, 2, 3, 4 terms. So it is a polynomial. Okay, so our next one is raised to the 2nd power. So this would make this a quadratic. It has 3 terms. 1, 2, 3. So this makes this a trinomial. Okay. Adding and subtracting polynomials. If subtracting, change it to addition and change all signs in the polynomial behind the minus. So we will distribute the negative sign. Add like terms. Add the coefficients and keep the exponents. Be sure your final answer is written in standard form. Okay, so make sure when you are adding, you add like terms, which then you add the coefficients and keep the exponents. Let's try some examples. So we have 4x plus 1 plus 6x minus 8. Okay, so you need to rewrite this so that the like terms are aligned. So 4x plus 1 over 6x minus 8. Okay, let's add like terms. So 4x plus 6, so 4 plus 6 is 10. And then we keep the exponent the same, so x. And then 1 minus 8 is negative 7. So our answer would be 10x minus 7. Okay, let's try our next example. So we have 2x squared plus 3x plus x to the second power minus 3x plus 7. So make sure that you align your like terms. So 2x squared needs to go with x squared, and 3x needs to go with negative 3x. And then our 7 is off to the side. Okay, now let's add. So we add the coefficients. So 2 plus 1 is 3. 2 plus 1 is 3. We keep our x squared. Then 3x minus 3x is 0. So those cancel out. And then we're left with just the 7. So this would be 3x squared plus 7. Okay, let's try our next example. We have x to the third plus 2x minus 3. Remember to align your like terms. Then we have minus 2x to the third plus 5x minus 6. So we need to distribute our negative sign. So that will become negative 2x to the third minus 5x plus 6. So again, we are distributing our negative sign. So the negative needs to go to all three terms. So that becomes negative 2x and negative 5x. And then two negatives makes a positive, so plus 6. Okay, now let's add like terms. So 1 plus negative 2 is negative 1. So it becomes negative x to the third. And 2 minus 5 would be negative 3. Then we keep our variable, x. Then we add negative 1 plus 6, so 5. So our final answer would be negative x to the third minus 3x plus 5. Okay, let's try one more example. So we have 5x to the fourth and minus x plus 3, and then negative 5x to the third minus 2x minus 1. So if you guys notice, we do not have like terms starting, so we need to make sure that you skip a little bit of space when adding. So we need to distribute our negative sign. So this becomes negative 5x to the third plus 2x minus or plus 1. So again, we're going to have 5x to the third, negative 5x to the third, plus 2x plus 1. Now we need to combine like terms. So I'm just going to bring down my 5x to the 4th because I have nothing to add it to. In addition, I'm going to bring down my negative 5x to the 3rd because I have nothing to add it to. Then I'm going to add negative x plus 2x, so that becomes x. And 3 plus 1 is 4. So our final answer is 5x to the 4th minus x to the 3rd plus x plus 4. Okay. Find the perimeter of a rectangle if the length is 5x plus 3 and the width is 3x minus 2. So first off, what is our equation for perimeter? Perimeter equals 2 times the length plus 2 times the width. So we are going to substitute in our values for length and width. So we're going to get our perimeter equals 2 times 3x minus 2 plus 2 parentheses 5x plus 3. So my first step is going to be distributing my 2. So I'm going to get 6x minus 4. And x plus 6. So now we need to combine like terms. So I'm going to rewrite my equation where I can add like terms. So 6x minus 4 over 10x minus 6. So 6x plus 10x is 16x. And negative 4 plus 6 is 2. So our final answer would be the perimeter is 16x plus 2. Okay. The number of educational and commercial internet sites since 1991 can be modeled by the equations below. Find the total number of internet sites, S. So what I'm going to do is add like terms. So we will add 0.99t to the second plus 0.3 321 t to the second. That would be 0.42 t to the second. And then we will add 0.120 t minus 1.036 t, giving me negative 1.156 t. Then we'd add our constant, 0.295 plus 0.968, giving me 0.993. So S equals 0.42 t to the second minus 1.56 t plus 0.993.